Hey, how you going? It's Patrick from North Australian Heavy Mechanical. First up, I just want to say thanks very much to everyone for getting on board. I've just cracked 1,000 followers in just over 5 weeks, so I'm actually stoked. I can't believe that so many people have converted and jumped over and checked out the long form. Anyone can sort of make reels, and to stand there and talk about an excavator for 10 to 15 minutes and have people tune in and enjoy that is really cool. I'm really passionate about these diggers, and I really want to keep making these videos and progressing the videos and adding more context to them as the time comes on. Obviously, it's a little bit limiting at times. I still have to maintain a job and work, so you can't just be getting around with the phone out and taking videos all the time. It's one of those things where I just have to, chip away at it and give you the best context I can with the tools I have. So basically today I'm going to give you a bit of context on one of the reels that I did, and it was travel deviation on a little 9100, and at the time it was a failed rotary connection. So I basically just went through the motions of how to diagnose a rotary connection. So I'm going to give you a bit of an overview of what's in a travel circuit, and this will help you understand moving forward how you can apply these principles to your travel circuit. So basically it's about learning what's in the circuit and then how we can compare it when it comes to travel deviation or travel issues, how we can use our attachment to compare what results we're getting. So basically what's in the circuit is you have pumps, valve banks, secondaries, rotaries, motors and final drives. So when you break it down like that, it just makes it a little bit simpler. So basically what a rotary connection is it transfers hydraulic flow from your superstructure down to your car body, and this allows for rotation of the machine. So it's basically a big cylinder. The top half stays with the superstructure, and the bottom half will rotate with the car body. So it's basically a cylinder that slips inside another cylinder that has ports. So all your high pressure hoses from your valve bank go down through it, and it has basically stacks, and all those stacks are as seals, and that is what they're all ported. So when you push right hand travel, oil comes down through and goes out through that, and that allows it to rotate. Basically works like a gyro on a push bike, when you were a kid, and so that you'd spin the handlebars freely. Basically the same sort of principles as that. So the rotary connections are, they're a serviceable item, and I think they're about 10 to 12,000 hours. But next I'm going to go through some pump and valve bank configurations, sort of just to give you a bit of an understanding of how you can go about comparing a travel deviation issue to your attachment to work out where the problem will lie, whether it's going to be a motor, a final drive, a secondary, or it's going to be a flow issue coming out of your pump. So basically, first up I'll give you a 9350, for example. Pretty basic setup. Has 4 main pumps and 4 valve banks. So valve bank 1, valve bank goes to pump 1, so on. So 3 and 4 do your travel. They have 2-stage reliefs on these ones. They punch their travel up to 350 bar. Basically, 1 valve bank does left travel, 1 does right travel. So, for example, if you have slow travel on one track, they both share a Y3, so it sort of rules that out. And then you can compare it with cycle times and pressures to the attachment, right? So that valve bank will have boom up, so you can pull boom up. If you've got, say, a stall relief on your track of 260, and then you go boom up and you've got 320, chances are it's not going to be a main relief or a valve bank issue. It's going to be down the line you've got a pressure loss in that circuit. So you can then go and single pump cycle time it pretty quickly, or say cycle time the attachment and see if that's slow on that 1 valve bank, and then cycle time your track, and if the attachments on that 1 valve bank is up to speed, then your cycle time on your track is, you're going to be looking for a motor secondary or a rotary connection on that. And then it's even easier with the twin engine thing. So for example, 996 pumps 1 and 3 on both power packs go to valve bank 1 and 3, believe it or not, and then they do your left and right travel. So knowing this, you get called to a travel deviation fault. It's traveling one way or the other. Pretty quickly you can work out what's going on. So if you travel it one direction, yep, it's traveling that way. And then basically you go to single engine, you travel one the other way and it's dead straight, and then you go and start your other engine up and travel it on that one engine, and then it's pulling that on one engine, it's pulling to the right or whatever it is, you know that it's going to be a regulation issue, and one of those pumps probably just needs tuning. And then, for example, you can then compare your stalls on that track for, it should be 320. If you got like 260 on your stall on that track on that valve bank, so valve bank 3's got 260 for stall on your track, and then on your attachment for boom up it's got 320. You know that it's not going to be a main relief, it's going to be a pressure loss in that circuit. So for example, RH400s, they use 1 and 8 for right hand travel, 2 and 7 for left hand travel, and they go via the travel block, which is on top of your rotary connection. They punch their cutoffs up to 3. They punch the cutoffs up, and then the main reliefs are set to 380. So, with those ones, it's again even easier to really rule those ones out, because you can just do single pump cycle times with your attachment and compare one side to the other pretty quickly and work out if you've got an issue with one of those pumps. So that's why it's super important to know what's in the circuit, So I'll go over a few things there again. And the Liebherrs on the 9400s, 9350s, the little diggers, they love to use a 2-stage relief. And this 2-stage relief is what punches that main relief. They punch 30 bar in on top of that main relief when you go to travel, and basically it punches the main reliefs up to 350. And then on the ONKs, they give priority flow to the travel circuit on the RH400s. So when you go on tram, those valves, the travel blocks on top of your rotary connection, basically gives priority flow to the travel circuit, and then they use travel boost, which then pumps the cutoffs up on those pumps. So I'll give you a bit of context around rotary connections and some of the complaints that you get from these rotary connections, because they are serviceable item. They do fail from time to time. So some of the rotary connection complaints that you get from operators is that they're basically skidding off the bench. So it's very unstable when it's coming off the bench. It seems like it's skidding off the bench, as some have described it as. And then they'll say, when I'm digging, the digger keeps pulling through the tracks or pulling through the park brake, is the other one that I've heard quite often. And so why that is when those travel spools are in the neutral position, either side of that motor will be shut off to both supply and return. So it should be dead-headed, that motor. But if the rotary connection is failed, then the oil will be able to transfer from one side of the motor to the other. So to rule this out, you can work it out pretty quickly. Basically, go and release your travel brake and see if that rotary connection, if those tracks, when you pull a bucket towards it, it shouldn't pull through the tracks, right? Because technically it's dead-headed, which it is. But if those rotary seals in the rotary connection have failed, the oil takes the least path of resistance and it'll cause those motors to turn over. So another test you can do with this is basically go and jack one track up. For example, jack your left-hand track up, go and stall so if you can, jam the right-hand track out. On the smaller ones, it's easy. You can just put a socket in them. But the big ones, what I find is just basically bring that right-hand pedal with the left-hand track in the air, bring it on nice and slow, and don't go flat out, because it just the machine just trams. But if you bring it on nice and slow, you will see the left-hand track. This is had this quite a few times where the left-hand track will turn, because the oil's obviously taking the least path of resistance and turning that left-hand motor off, and that's a dead giveaway, especially if valve banks 3 and 4 do left-hand and right-hand travel on their own. you definitely got a bypassing rotary, and that tells you pretty quick. So, you know, basically I've had a few different situations where, you know, you can pretty quickly compare tramming circuit faults to your attachment, and it'll tell you exactly what's going on. So for example, 9400 travel deviation, basically was towards the end of shift, so I was in a bit of a rush and I wanted to work it out. Basically they were complaining it was traveling one way really badly, so I quickly stalled that suspect track out, and it had like 260 bar. So then I stalled my attachment out, and I had 320 bar on my attachment. So I sort of was like, well, definitely it's going to be a major pressure loss down in the travel circuit, and then went down and had a quick look at the final drive and noticed a heap of oil. So the motor had actually come loose on that one, and that was what was causing the pressure loss. That motor was not engaged correctly with the final drive. So you know, some other ways that you can test the motors is basically temp shooting motors and casing motors as well too. So another travel deviation one I've had a few times with rotary connections, but is just basically operators complaining about lack of spragging and travel deviation, or, you know, skidding off the bench. So those ones are just little 9100, for example, just basically try and pull it through the tracks with the park brake release. You know, at first put the park brake on, try and pull through the tracks, then release the park brake, and then see if you can pull through the tracks, because you shouldn't be able to, because that spool's in the neutral position. It should be dead-headed, and it won't allow those motors to turn over. So that's why it's really important to, when the machines, if you are working on these machines, you got to work out which valve bank and which pumps work together to give you travelling, because you know, you can then work out really quickly if you have a problem in one circuit, or it's a common fault, and, you know, it's going to be a flow or a regulation issue, or it's going to be a main relief, or it's going to be down the line in your travel circuit. So basically, just want to give you a bit of an overview of the circuit today. I will deep dive a bit more into the Liebherr control side of things eventually, but today I just wanted to give you some quick points to help you understand what's in a circuit, what a rotary connection is, and no, the digger doesn't unwind itself if it swings too many times in the one direction. So cheers for the support, like, share, comment, as always. Cheers.